Hi, and welcome to this session on working with ACS Policies for Red Hat Advanced Cluster Security. My name is Eric Bannon. I am a Senior Specialist Solutions Architect here. So a couple things that we're going to cover in the demo and enablement working session are first, an introduction to ACS Policies. We're going to give you a policy management overview. There are a lot of default policies that are built into ACS regarding best practices for container security, as well as deployment configuration and other types of use cases. There is a way to integrate these policies directly to third-party notifiers so that you can be told when you're in violation of these best practices. There's also a capability to create custom policies and also to check for those violations in a CI/CD process using the rockctl ACS command line. This is typically used so that developers can get quick access to being able to fix or remediate the policy violation based on the guidance that's actually explicitly stated within the policy. And again, these can have anything to do with vulnerabilities, configuration, elevated privileges, and so on. So in the preceding demonstration inside the ACS control plane, we're going to show you each of these 6 things and give you an overview of everything listed on the screen. So just to give a little bit of a high-level overview, ACS comes out of the box with 84 default policies that align with container security best practices. These include, but are not limited to, trusted content, vulnerabilities, container configuration, deployment configuration, anomalous executions at runtime, exposed networking or services for the Kubernetes deployments, excessive privileges, sensitive data, as well as regulatory compliance. Policies in ACS are primarily designed to notify security administrators when there are existing violations of these best practices. And shift left security is really the goal of a lot of this, in that containers are immutable. So fixing certain violations related to vulnerabilities and configuration doesn't really make sense in the context of patching it inside the live environment, but actually with everything defined in code and everything developed by the developer, we really need to inform them and include them in the security administration process. So the idea would be here, as we referenced in the earlier slide, to use the rockctl ACS CLI in order to insert policy checks within your development pipelines and deployment workflows. The other thing that ACS is able to do with the policy engine is either inform or also turn on enforcement for these policies across the entire container lifecycle. That includes the build phase, which has policies around how the image is compiled, its trusted content, where it's coming from, how old it is, its vulnerabilities, to deploy time, which primarily concerns itself with policies around the configuration of the deployment, network exposure, and network policies, to runtime, which has to do with profiling and baselining the running container applications to see what is anomalous and what should not be executed. Custom policy creation allows organizations to tailor these policies to their specific container security program. While there are many default best practices, this is a powerful and easy to use policy creation capability that will give the organization the ability to further tailor the inform and enforce mode of these policies. So let's jump right into it. Demo part 1, let's go into the policy overview. So now we're in the ACS UI, and from the UI we can see a few different tabs on the left. Some of these are going to be covered in the other videos that are made available to you as part of this enablement. For the purpose of this, we're going to go into platform configuration and policy management. This is where you're going to see the 84 default policies that we mentioned in the previous part of this video. And you'll notice that we have them across different life cycles. So you'll see the build, deploy, and runtime phase for each of these types of policies. Now, build time policies typically have to do with things related to the image. Am I running package managers inside them? Do I have things like critical vulnerabilities like log4shell or spring4shell inside my image? making sure that I'm not running a root user, for example, or any other policies that an organization might want to create in order to catch things within the build of their images and containers as early in the life cycle as possible. In the deploy time, we see really best practices around the deployment's configuration and things you shouldn't be doing in terms of putting the deployment at risk for exploitation should a vulnerability or an attacker gain a foothold into it. This includes things like having fixable vulnerabilities of a severity of at least important that could be taken care of by the developers, deployments with externally exposed endpoints, which makes it more likely for an attacker to be able to leverage or exploit an existing vulnerability. We have different things around mounting the runtime socket, mounting container volumes that are in read-write, and so forth. The other thing that ACS does is we also profile the running containers for the processes that we expect to execute. So one of the things that we do here is across the environment, we actually baseline all of the running processes within each of your deployments. And then we flag anything that's anomalous or outside of the expected behavior. So there's a specific policy for this in the runtime lifecycle that is called an anomalous process execution. And basically what that policy does is it automatically includes anything that is not part of the container's baseline. In addition to that, we do have explicit known bads for policies. So things like, are the containers or people inside them trying to add additional users or groups? Are there package manager executions to try and install additional packages from the internet? Is someone trying to move laterally within the network or copy files to exfiltrate data out, and so forth and so on. So by default, all of these are tied to violations. And you'll see that across my environment, I've got about 388 violations. I can see explicitly in my runtime environment with all my existing deployments and images where I am in current violation of this. And if I wanted to, I could also tie these to third-party notifiers. So if I wanted to send this to Jira to open a ticket, to Splunk, generic syslog or webhook, I can also send those violations there. Now, let's go into a specific policy. So we'll do the log4shell vulnerability policy because that one tends to be a pretty important one these days. And what I can do here is I can edit this policy and I can begin to see a few different fields within this. So the first is the name, the severity, the category, description, rationale, and the guidance. And this guidance is really what the developer is going to use in order to understand what they need to do to remediate this. So this would be the same information that they get within their CI/CD pipeline should you integrate the CLI, and they'll be able to understand this. Under policy behavior, this is where we begin to get into the inform and enforce mode. I'm going to save this for the next session so that we can actually demonstrate what this looks like, but there is the ability to turn on enforcement, which we will get into here. Policy criteria is defining what the policy is looking for to meet the criteria that represents a violation. In this case, it's matching the associated log4shell CVEs. Policy scope has to do with particular scopes that I want to include this on. So maybe I want to just add a scope for a specific cluster, namespace, or label. Maybe I want to exclude certain deployments because we've already mitigated the log4shell vulnerability by doing some other things, or I also might want to exclude specific images. Once I'm comfortable with the policy, I can review this and I can save this with any changes that I've made. And as we'll see in the environment, this policy is actively being managed within the violations. If I were to search for this, for example, and go into policy, type in log4shell, I'll see that I currently have one representation of this violation. Let's proceed to the next session. Now that we've had a chance to give you a general overview of the policies, let's go into the enforcement options for each of these. And in this example, we're going to use the log4shell vulnerability to demonstrate what this looks like, specifically at deploy time. I'm going to go into the Log4Shell vulnerability, and I'm going to edit the policy. And as we expressed in the previous video, under policy behavior, this is where you'll see a couple different things. The first is the lifecycle stage. So depending on the type of policy, certain things will be enforceable at the build or deploy phase or the runtime phase. In the case of a vulnerability or the case of a configuration, it doesn't make sense to enforce this at runtime because that actually wouldn't do anything to remove the vulnerability or update the image in the environment. What really needs to happen for these types of policies is they need to be implemented earlier in the life cycle, ideally when the image is being created or deployed through a CI/CD workflow, or in this case, if I also wanted to block it at deploy time. So ACS ships with the default admission controller. All of the default deploy policies are tied to that. And what this means is that even if I don't check for the vulnerability at build time, if I want to evaluate that when the application is being deployed, I could also inform and enforce at that stage. Now for the build time enforcement, if I include this and I have the rockctl CLI within my CI/CD pipeline, if it detects a violation of this policy, it returns an exit code to that pipeline, and it actually shows the developer why it failed and what they need to do to remediate to proceed past that violation. If I enforce this at deploy time, what this is going to do is leverage the admission controller to prevent that deployment from actually getting deployed to the environment. So what I'm going to do is I'm going to click next, and I'm going to save this policy with enforcement turned on. And now let's actually show you what this looks like. So what I'm going to do is I have an OpenShift environment, and I'm going to go ahead and I'm going to go into my environment, and I'm going to find a particular demo YAML that is bad. So in this case, I have it labeled badapp.yaml, and I'm going to try to actually create this. And so what I'll see here is that in my UI, I have a block deployment create with a violation of that policy. And as a developer or someone who had just attempted to deploy this, I actually get the information on why this was denied. So it says that it failed due to one enforced policy, the policy name, as we showed you in the previous fields, the description, the rationale, the remediation, the specific CVEs that were found in the version of Log4j that's running, and the remediation to upgrade this to 2.16 or later in order to remediate. Now, enforcement can also be turned on for things like runtime events. So let's say that you had a executable in your environment that you did not expect. If I turned on any of the policies for runtime, what this essentially does is it goes ahead and it kills the pod when it detects that anomalous execution within the container. It's important to note here that this is Kubernetes native. What that means is that you don't want to kill a process or the container itself because that might impact the application's availability. The correct way to do this, in our opinion, is to kill the pod, exit the attack, so it'll mitigate whatever is being executed or whatever's in progress of being executed. And it will go ahead and it will inform you in the same way that it just did for the build and deploy time policies. So you have a lot of options for enforcement. You have a lot of options to be notified when things are enforced, the number of times they've been enforced, and all of the data behind that. And this is a powerful way to use the policy engine to prevent and address security risk within your environment. The next part of our enablement session will be part 3 of the demo, creating a custom policy. In addition to the default policies that we've shown you thus far, there's also the ability to create a custom policy that might better fit some of the unique use cases for your organization. Now, under the policy management tab, I'll see an option to create a policy, and let's go and actually use an example here. So I'm going to create a policy, and these policies can really span any type of criteria: build, deploy, runtime. I'm just going to call it test policy for now. I'm going to label it as high, and I'm going to select the category, which you can also create your own category if you'd like. I'm just going to call it DevOps best practices. Not going to include the description just for the sake of time, but just put different things here. So if the good thing about this is for your own paper policies, if you wanted to include specific guidance for internal processes you'd like the developers to follow, it's a good place to put that, since as you saw in the previous section, all this information will be shown to them in their pipeline or at deploy time or in runtime when they are in violation of a specific policy. I'm going to pick the build and deploy time, and I'm going to leave it on inform mode. Click next. And so here I'm going to see different types of criteria depending on the life cycle that I just picked. In this case, I have image-based criteria such as, is it coming from a specific registry? Do I want to verify that it is a signed image that's coming from one of our approved registries? Do I maybe want to look for a specific image label that I require the developers to have? Or even looking at a grace period for CVEs. So maybe I want to say, this is 30 days since the CVE was discovered, and I want to only notify them if that grace period of 30 days has been surpassed. Now, in the previous section, if I were to change the life cycle, different things would happen based on what this is looking to address for those specific violations. So here, in a deploy time policy, I'll see additional things: container configuration, deployment metadata, storage, networking, and Kubernetes access. So as you can see, we support Boolean operators, which makes this very, very easy to create a lot of combined criteria. So for example, maybe I want to create a policy around privileged containers that also have an externally exposed port. And so maybe I want to understand where I'm running privileges with network exposure. Maybe I want to create a policy around capabilities to read or write the file system. So there's different criteria here that you'll see for a read-write root file system. I want to know if it's privileged and it's able to do that and modify anything in my environment. But as you can see, you're able to create a lot of different custom policies based on the criteria you want. We can add conditions. We can add and or conditions for the Boolean operators, so it makes this very easy to create the type of criteria that you're looking for. Once you're all set, you go ahead and click Save. And now you'll see that this policy is now in my environment. Test policy, currently have it enabled, and I can proceed to incorporate this into my notifiers or turn on enforcement if I desire. For the last part of our enablement, we're going to cover the CI/CD pipeline checks for policy violations using the ACS RockCTL CLI. Let's take a look. In the UI, you'll see that you can download this CLI directly from the control plane. Once you have that deployed, RockCTL gives you a few different options in order to check the images and the deployments. So if I look at the available RockCTL commands, I'm able to do a lot of things with this that have nothing to do with policies, but I'm also able to do a couple different things with the RockCTL image command. So RockCTL image check will validate the image against any of the build time policies and report them. A scan will run a raw scan of the image. So essentially within a pipeline, all you need to do is incorporate RockCTL into that pipeline, where we have many examples of integrating this with different tools like GitLab, Azure DevOps, OpenShift, Tecton Pipelines, Jenkins, and more. But it's the same process for any of these technologies. So as an example, I've already got one configured. This is one of my trusted supply chains using Tecton. I've got an entire pipeline that is building a application from source code, fetching dependencies, building the container, inspecting the image, running a scan on that image to detect all the critical and high vulnerabilities. And then I've also incorporated a ROC-CTL check into this with enforcement that's been turned on for specific policy violations. So similar to the enforcement we showed you in the deploy time policy for Log4Shell, this is what the developer would see for this check. Now, I've turned it on for Spring4Shell and Log4Shell, so it returned an exit code to my pipeline, but it gives me all the policy information in those fields we went over earlier in the enablement. What is my remediation? What is the current version of the impacted part of my image? And then even things that you might not have turned enforcement on, like fixable severity of at least importance, so additional CVEs that could be easily fixed by upgrading to the recommended version, and additional policies. Now, if I did not turn on enforcement, this would allow my pipeline to continue to go through with the creation of the image and would still notify the developer of the same information. We hope you've enjoyed this enablement session for Red Hat Advanced Cluster Security Policies. If you have any additional questions, please follow up with us and we'd be happy to schedule a private session to review more. Thank you and have a great day.